Hello friends, in this module we will learn about paper and paper based products. Paper is the most versatile packaging material available in the market today. So in this module we will learn about paper making process, the various applications of paper and paper boards for food packaging. Paper and paper based materials are the oldest and most versatile packaging materials available on the market today. They are ionic material. They can be permanent or temporary, gentle or strong, cheap or expensive, in plenty or maybe limited. They can be preserved in a museum or maybe thrown away. They are made and used by the millions of tons or maybe so rare that only a few tons of handmade paper are produced in a year. Paper and board, alone or associated with other materials, has been used in food packaging for food contact for many years. A particular effort for alteration to the environmental concerns and the user's need was made at the same time as the use of paper and board was increasing. Paper and board is indeed an essential part of our lives and satisfies many human needs. We use it to store and communicate information. For example, in forms of newspapers, books, documents, and even writing paper. For cultural and artistic purposes, to transport and protect goods like packaging sacks, liquid packaging boards, etc. And for personal hygiene also, like tissues, napkins, nappies, etc. So in the slide, we will learn about what is paper. Paper is made from the wood fibers, and around 97% of paper produced today is made from the wood fibers, and around 85% of the wood fibers are acquired from the softwood like spruce, birch and pines. But the paper can also be manufactured with recycling materials like the old newspapers, old paper. They can also utilized and can be made into paper again by recycling. Cellulose is consisting of long ribbon-like molecules made up of smaller glucose units. The glucose units are formed from atoms of carbon, hydrogen and oxygen. These molecules are held together side by side by hydrogen bonds to form sheets, which in turn are piled together in tightly packed layers to form microfibrils. The microfibrils group themselves in bundles, and groups of these bundles form the paper fiber. Paper is called board when it is heavier than 224 grams per meter square. The demands placed on the form of paper and board vary widely with the intended use, but some are common to all grades. That is, the paper must be strong enough to fulfill its technical function and also be able to printed upon in a way that makes it striking to the customer. Paper and board can be used in contact with food in many different ways, either directly or indirectly, and either singly or laminated with other materials such as plastics, metal foil, etc. In the latter case, so called functional barriers are aimed at suppressing any substance transfer between food and base paper material. Now we will discuss about manufacture of paper and board. Paper and board has a long history, beginning with ancient Chinese and continuing to the present day. While handmade methods dominated for thousands of years, paper production became industrialized during the 19th century. The first machine to manufacture paper continuously was invented by a Frenchman, Louis Nicolas Robert, in the year 1799. Originally intended purely for writing and printing purpose, a wide variety of paper grades and uses are now available to the customer. Each paper or board grade is produced on equipment tailored for this particular grade and mill. Production processes are optimized for each grade. There are many variables like raw material consumption, pulp, recovered paper, fillers, pigments, additives, etc. Machine size, type of production equipment, and automation level. Paper and board production involves two steps. First, the fibers need to be produced. This is done in a pulp mill where pulp is produced using chemical or mechanical process. Pulp production can be integrated with paper production, or the pulp can be produced in a separate pulp mill. The paper itself then produced on a paper machine from mixture of fibers, chemicals and additives. All paper and board machines are based on a similar basic process. There are 7 distinct sections: head box, wire section or wet end, press section, driver section, size press, calendar and a reel up. Now we will talk about preparation and the cleansing of pulp. The untwist this section untwist the fibers. Beating is a mechanical treatment intended for swelling, fibrillating and shortening the fibers. The result is a better sheet formation and the development of paper's mechanical properties. Before sending to the paper machine, the pulp is initially purified, diluted, and air bubbles are eliminated. Sometimes pulp is also bleached if made from recycled paper, as recycled paper gives around a greyish tinge, so the bleaching is necessary. The wet end part includes raw material fibers and chemicals and around 99% of water. All the things are mixed and pumped to head box, which feeds the stock evenly onto the wire section. This is a woven plastic mesh conveyor belt that can be 35 meters long and up to 10 meters wide. As the paper stock flows from the head box onto the wire, the water drains away through the mesh, leaving the small fibers as a mat on the top of mesh. The paper machine can travel at a speeds of up to 2000 meters per minute, and by the time the paper stock has traveled halfway down the wire, a high percentage of water has drained away. By the time the thin mat of fibers has reached the end of wire section, it has become a sheet of paper, although very moist and a little strength. Now, the press section. This section consists of a number of sets of felts and heavy cylinders through which the moist paper web passes. More water is pressed out to felts and drawn away by the suction. Pressure binds the fiber together and consolidates the web. Next is the dryer section. In this section, the large number of steam heated drying cylinders are there, which have a temperature of slightly over 100 degrees centigrade. Synthetic dryer fabrics carry the paper web round the cylinders until the paper is dry. Another section is coating and calendaring section. In many applications, the surface of the sheet needs improvement in order that any characters imposed on the sheet be legible. This is achieved by calendaring, a process which reorients the surface fibers in the base sheet of paper by the use of pressure. This serves to smooth the surface, control surface texture and develop a glossy finish. Such papers are known as machine finished papers. The next step in paper making process is finishing. At the end of drying process, the sheet is smoothed using ironing method, which consists of hot polished iron rollers mounted in pairs with synthetic material rollers, one above the other. This also helps to consolidate, polish and glaze the surface of the paper. The characteristics of the surface of the sheet are improved. The next step is shipping. Still traveling at a very high speeds, the paper comes off machine ready for reeling up into large reels, or they are also known as parent reels, which can be cut or slit into smaller ones according to the customer requirements. These large reels are produced and changed without any interruption of the production process. The quality control is also important for the manufacture of paper. So the sensors and computers verify parameters such as production speed, the pressure, and the resistance at every step of the process to ensure that the paper or board is of the consistency which is desirable or the product is made of very high quality. Moreover, for food contact applications, microbiological, chemical, and organoleptic controls have also to be carried out. A board machine often has several formation devices in the wet and producing a multiple sheet combined on the forming table and press. The basis weight of the boards can be as high as 500 grams per meter square, whereas the printing and writing papers are usually 40 to 120 gram per meter square. Paper and board machines are each different. The size of the production capacity and technology varies. Each one is tailored to the specification of the paper mill. The next section of the module is recovered paper and board. The recovered or recycled paper is an important raw material in terms of volume and utilization of paper industry in many countries. The recycling of paper is an example of sustainable use of resources. Although recycling is both economically and ecologically sound, recovered paper cannot be used in all paper grades. The final production process for recycled paper is the same as the process for paper made from primary fibers. The main difference is that recovered paper fibers have already been used, so that non fiber material will have to be removed. The major steps in the recycling process are collecting and transportation. Recovered paper is sorted, graded, formed into bales, and paper mill. Repulping and screening is the next step. After reaching the paper mill, the recovered paper is mixed with water and chemicals, which separates the paper into individual fibers. The pulp mix is then diluted with water and passes through a system of centrifugal cleaning equipment and screens. The pulp is filtered and screened through a number of cycles to make it more appropriate for paper making. This is done to remove large contaminants like wood, plastic, stones, glass, and paper clips, along with small contaminants like string, glue, and other sticky material. Pulp is cleaned in a large spinning cylinder, and the heavy contaminants move to the outside of the cylinder and they are removed. The next step is de-inking. It is also very important because the reused paper is printed. So, for de-inking, the sanitary and domestic papers of packaging material are recovered, and then the fibers have to be de-inked. The de-inking process can be carried out by flotation, with or without washing, with or without kneading, and with or without bleaching. The finished recycled pulp is now ready to be made into paper and is either sent on a mile long conveyor to the mill for paper making or formed into sheets of pulp or shipment and sell. Depending on the grade of paper being produced, quantities of virgin pulp from sustainable source may be added. Some papers, such as newsprint and corrugated materials, can be made from almost 100% recycled paper. Once the paper is used, it can be recycled and the process starts again. Individual fibers will gradually be degraded in the process, so a continuous addition of new fibers is necessary to sustain the recycling cycle. There are different grades of recovered paper and board to satisfy the needs of different producers according to the specifications. More than 50 grades of recovered paper and board are defined in the European list of standard grade recovered paper and boards. They can be described as follow. First one is low grades. These are used to produce secondary packaging papers and boards and are not intended to be in direct contact with the food. De-inking grades, they are usually also considered as low grade because they need extensive recycling treatments. These are for the graphic and sanitary papers. The third one is high grades. They require little or no cleaning. They can be used for production of any paper product as pulp substitute. They may therefore be suitable for food contact packaging also. So now we will discuss about different types of paper. It is divided into two broad categories. Fine papers, generally made of bleached pulp and typically used for writing paper, bond, ledger, book and cover papers, and coarse papers, generally made of unbleached kraft softwood pulps and used for packaging. So in this, first we will take kraft paper. This is typically a coarse paper with exceptional strength, often made on a Cordier machine and then either machine glazed or Yankee dryer or machine finished on a calendar. It is sometimes made with no calendaring so that when it is converted into bags, the rough surface will prevent them from sliding over one another when stacked on a pallet. Another type is bleached paper. These are manufactured from pulps which are relatively white, bright, and soft and receptive to the special chemicals necessary to develop many functional properties. They are generally more expensive and weaker than unbleached paper. Their aesthetic appeal is frequently augmented by clay coating on one or maybe both sides. Next is a grease proof paper. This is translucent machine finished paper which has been hydrated to give oil and grease resistance. Prolonged beating or mechanical refining is used to fibrillate and break the cellulose fibers, which absorbs so much water that they become superficially gelatinized and sticky. This physical phenomena is called hydration and results in consolidation of the web in the paper machine with many of the interstitial spaces filled in. The satisfactory performance of grease-proof papers depends on the extent to which the pores have been closed. Provided that there are few interconnecting pores between the fibers, the passage of liquid is difficult. However, they are not strictly grease-proof since oils and fats will penetrate them after a sufficient interval of time. Despite this, they are often used for packaging butter and similar fatty foods since they resist the penetration of fat for a reasonable period of time. The next type is glassine paper. Glassine paper derives its name from its glassy smooth surface, high density and transparency. It is produced by further treating grease-proof paper in a super calendar where it is carefully dampened with water and run through a set of steam heated rollers. This results in such intimate interfiber hydrogen bonding that the refractive index of the glassine paper approaches to 1.02 value of amorphous cellulose, indicating that very few pores or other fiber or air interfaces exist for scattering of light or allowing liquid penetration. The transparency can vary widely depending on the degree of hydration of the pulp and the basis weight of the paper. It is frequently plasticized to increase its toughness. Next class is vegetable parchment paper. It takes its name from its physical similarity to animal parchment, which is made from animal skins. The process for producing parchment paper was developed in 1850s and involves passing a web of high quality unsized chemical pulp through a bath of concentrated sulfuric acid. The cellulose fibers swell and partially dissolve, filling the spaces between the fibers and resulting in extensive hydrogen bonding. Thorough washing in water followed by drying on a conventional paper making dryers causes re-precipitation and consolidation of the network, resulting in a paper that is stronger wet than dry, free of lint, odor and taste, and resistant to grease and oils. Unless specially coated or of a heavy weight, it is not a good barrier for gases. Because of its grease resistance and wet strength, it strips away easily from food material without defibering, thus finding use as an interleaver between slices of food such as meat or pastry. Labels and inserts in products with high oil or grease content are frequently made of parchment paper. It can be treated with mold inhibitors and used as a wrap for food such as cheeses. Next class of paper is waxed paper. Waxed paper provide a barrier against penetration of liquids and vapors. Many base papers are suitable for waxing, including grease-proof and glassine papers. The major type of wet waxed, dry waxed, and wax laminated. Wax sized papers in which the wax is added at the beater during the paper making process have the least amount of wax and therefore give the least amount of protection. Wet wax papers have a continuous surface film on one or both sides, achieved by shock chilling of waxed web immediately after application of wax. This also imparts high degree of gloss on the coated surface. Dry wax papers are produced using heated rolls and do not have continuous film on the surfaces. Consequently, exposed fibers act as wicks and transport moisture onto the paper. Waxed laminated papers are bonded with continuous film of wax which act as an adhesive. The primary purpose of wax is to provide a moisture barrier and heat sealable laminate. Often, special resins or plastic polymers are added to the wax to improve the adhesion and low temperature performance and to prevent cracking as a result of folding and bending of the paper. Now we will discuss about the application of paper and paper boards in food packaging. So, natural or bleached, rubbed or coated or associated with other materials, paper can be found in the shape of bags, for example, for fruits and vegetables, or it can be a vegetable parchment paper. Then it can be converted into folding box board. It is often referred to as carton board. It may be single or multiply, wood colored or grey, coated or non coated, and it can present various properties like barrier to grease, humidity, gas, and it can be found in various shapes. It is mainly used in cartons for consumer products such as frozen food and for liquid containers. The next class is corrugated boards. It is brown and white, of low grammage or high density, resistance to bursting, to humidity or to compression. It can be found in different shapes such as showcases for use in stores or small boxes or mass market products. Corrugated cases constitute the highest volume of paper and board for food contact applications. For food contact applications, the package has to be strong enough to protect the food. It is generally printed to ensure its attractiveness to the consumer because it is part of the food delivery structure. To a limited extent, some barrier properties are expected to protect the food against degradation by the external environment. Specific barrier properties may be obtained with dedicated chemical treatments or through lamination with other materials such as metal or plastic. There has been significant increase in the use of paper and paper based packaging in the past 50 years for many reasons. It is robust and flexible. Corrugated board can be used to protect delicate porcelain or large electrical items, but also delicate fruits and vegetables. It is practical because cartons can be delivered flat to the packager, reducing space and transport costs, and then it can be formed when it is used. It can be easily recycled. It is made from renewable materials, recovered paper and wood pulp. Thus, in conclusion, we can say that paper is a very versatile material. It is produced from cellulosic, naturally renewable fibers. It is therefore considered as environmental friendly material, being easily recycled, composted or incinerated after use. It may be used in food packaging applications within a wide range of grammages, being designed as wrapping paper, folding box board or corrugated board for direct or indirect contact like as primary, secondary or tertiary packaging. Other paper grades such as tissue paper may be used for occasional contact with foodstuffs. When paper and paper based products are intended or likely to come into contact with food, manufacturers follow relevant and acknowledged regulations and guidelines to design manufacturing processes and recipes and ensure the maximum consumer safety. So, in this module, we have learned about how the paper is being manufactured, its various sections, which are 7 in number, and what are the different applications and what are the different types of paper used for packaging material as a packaging material for food industry. Thanks.